Welcome to Edabon. For over 30 years, we have provided premier technical teaching equipment across the globe from our headquarters in Madrid, Spain. Every Edabon product is designed, manufactured, and quality controlled in-house by Edabon engineers under several quality standards. Our product range includes individual units, complete laboratories, and turnkey projects in 13 engineering areas, from physics to environment. We offer various units in the area of energy. Today we will discuss the wind energy unit called the EEEC. This unit has been designed to demonstrate the principles of wind energy conversion when using an aerogenerator. These include adjusting physical parameters such as the number of blades and the angle of attack of the blades, the wind speed, and the operation of a charge controller and inverter. The unit is supplied with a SCADA unit control system. The first part is the main unit. Let's take a look in more detail. All components are securely fastened to a frame made from anodized aluminum, which guarantees good stability and corrosion resistance. Other main components include a large fan, a wind tunnel in which air travels through towards the aerogenerator at the other end of the tunnel. Located below the wind tunnel are a DC charge controller, an inverter battery and battery charger, and an AC load module. Here is the DC load module. There is a no load option, two small lights that can be switched on or off with this switch, a rheostat that can be switched on or off with this switch. Both the small lights and the rheostat can operate at the same time, a small motor, or an output option. If the output selection is chosen, then the output is routed to the battery. If it is necessary, you can use the battery charger to charge the battery if it is too low at the start of a test. You can connect the battery to the inverter, which converts the DC electricity to AC electricity. This AC electricity can be used to power a fan, a single lamp, or two AC lamps at the same time. Here's the AC load module. It has a few different options that can be selected. There's a no load option, an option where a fan can be turned on, an option with one AC lamp, or two different AC lamps. The second part of the EEEC unit is the control interface box. All information from the unit passes through the interface box before going to the computer. On the front panel of the interface we can find the on-off switch for the unit, the temperature sensor input, airspeed sensor input, DC voltage and current sensor input, AC voltage and current input, and a unit diagram, which shows the layout of the components in the unit. The system also includes a National Instruments data acquisition board, which, installed on the user's computer, collects data at a rate of up to 250,000 samples per second, which it then can store and graph. Edabon uses a software package that allows computer control, data acquisition, and data management. It is based on the well-known program LabVIEW. Before we start using the unit, I will explain the layout of the software. The main controls are in the upper left. This includes the calibration, start, stop, view data, save data, and quit buttons. A schematic diagram of the unit is displayed in the center of the page. The multi-control sensor displays an extra output. Parameters are displayed in the upper right. This includes air temperature, DC current, DC power, DC voltage, airspeed, rotational speed of the aerogenerator, AC voltage, AC power, and AC current. These buttons are used for data acquisition. Open control for the fan power, and therefore airspeed, can be found in the lower right. Data can be viewed in a table or plotted on a graph. We can manipulate the graph using these controls. After performing several exercises, we can compare results with previously recorded data. In addition, all necessary cables and accessories are included with each unit. Every unit comes with 8 manuals covering all topics concerning the operation of the unit. One of them includes several practical exercises that can be performed with the unit. Today, as demonstration, we will observe general operation of the unit by manipulating the fan speed. The user manual provides multiple practical exercises that walk the students through the correct operational procedure while teaching specific concepts. The sensor calibration allows the student to adjust the current gain, the current offset, as well as look at the voltage and calibration values. The user manual also provides multiple additional practical exercises that can be performed by the student. Here we have the entire computer-controlled EEEC wind energy unit. We can see the control interface box positioned between the computer and main unit. We turn on the control interface box and observe that the wind tunnel that is placed over the DC load module, battery, inverter, battery charger, and AC load module. Inside the wind tunnel is the aerogenerator. Now we'll briefly look at the components of the DC load module, which can be turned on with this power switch, and the different load options that can be chosen with this dial. There's a no load option, 2 DC lamps and a rheostat, a motor, and an output option. Here's the battery charger, battery, and inverter next to it, as well as the AC load module next to that. Here's the layout of the main unit program. We click Start to run the program. In the upper middle, there's the unit diagram. The upper right contains the sensor values. The bottom middle contains a graph. The bottom right contains actuators. And the bottom left contains the graphing controls. Here we are showing the actuator. This controls the fan speed. We can see data being plotted in real time. The sensor values displayed in the upper right are also in real time. We see as we change the throttle, we can see the sensor values change. We'll continue to do this. The sensor controls here in the bottom left will be used to display a graph. We selected the airspeed and changed the throttle, and we now see the live values of the sensors. We now select signal versus signal plot, and we will plot the voltage and the current. Here is a sample of the plot. Here are some examples of some results that can be obtained through this unit.
The key features of every EDIBON unit include Advanced Real-Time SCADA. The word SCADA is an acronym that stands for Supervision, Control, and Data Acquisition. SCADA is EDIBON's data acquisition and computer control system. Open control, multi-control, and real-time control. Open control is the ability to adjust or change parameters or conditions involved in the experiment at any time during the entire process. Multi-control means that the user has control over multiple parameters and can view the information from all sensors simultaneously. The system operates with real-time control. In other words, the computer receives information from the unit extremely quickly, which results in nearly instantaneous responses. EDIBON's software package is based on LabVIEW and allows computer control, data acquisition, and data management. The National Instruments Data Acquisition Board, installed in the user's computer, collects, stores, and graphs data. It is capable of taking samples at a rate of up to 250,000 samples per second. Calibration exercises are included with the unit, which are designed to help the user understand how to calibrate a sensor. This includes setting the gain, offset, and PTA, and viewing the voltage and calibration. These exercises emphasize the importance of checking the accuracy of sensors before taking measurements. Every Edibon unit is compatible with a projector and an electronic whiteboard. This provides the user with control of the unit remotely by simply touching the screen. This unit is capable of doing applied research, real industrial simulation, training courses, and more. It can also be operated and controlled remotely by the user or by an Edibon technical support engineer. Each unit is totally safe, utilizing 4 safety systems: mechanical, electrical, electronic, and software. This ensures that both the user and the unit are protected. Even in the event that one of the safety devices fails, the others will recognize the problem and shut off the unit. All Edibon units are designed and manufactured under several quality standards. Several expansions are available for each unit. Single student expansions are designed to aid a student in using the unit and provide more learning opportunities. They include the Programmable Logic Controller, or PLC. It provides direct control of the unit process with programming exercises and is comparable to the requirements of industrial processes. The computer-aided learning software benefits students by performing results calculation and analysis of the data taken. Also available is the computer-aided instruction software, which facilitates teaching for the professor by providing organization and control of exercises. It also offers the students detailed explanations of theories as well as practice exercises. Multi-student expansions are designed to assist multiple students in a classroom setting, such as the Edibon SCADA teaching system, which allows 30 students to work simultaneously and with multiple units. Edibon Technical Distance Learning allows connection via the internet to another location or central computer. The benefits of SCADA include providing students with clear concepts of industrial applications, reducing wasted class time and laboratory costs, and drastically increasing the efficiency of teachers and students. Finally, every Edibon unit comes with a 3-year guarantee against any manufacturing defect and components control for the lifetime of the unit. Due to the previously stated points, Edibon proudly provides full customer satisfaction. Thank you for watching this video. A link to our website can be found in the video description below. For more information, please contact us by phone or email. We look forward to talking with you.